The question you should ask yourself is, do you want to perform training with your clients or do you want to perform optimal training? If the answer is optimal training, then you should really be looking at effective movement training, our product at PT Academy. That was recently the subject of a clinical trial performed with employees of SAP in Australia. So what we did is we took 40 employees in two different groups. One of the groups did walking 10,000 steps a day, and they also got lifestyle advice. The other group did the same thing, but they came into PT Academy's gym, Acumotum, and they trained 3 times a week using EMT techniques. And at the start of the trial, the Brain Sciences Institute from Swinburne University performed a full neurocognitive battery. So these are assessing all aspects of brain function. They also performed mood assessments, and we did biological age testing or bioage testing on them. We then performed the intervention, which lasted for 8 weeks, and then retested. So here are just some of the results that have come out. So firstly, you see the control group, who were the walking group, and this is looking at alertness. And over the period of the trial, they didn't change their alertness, whereas those who used EMT 3 times a week had significant improvements in their alertness. Next up, we looked at vigour, so self-reported energy levels. You can see the walking group improved throughout the trial, but the exercise group, the EMT group, improved much more. And an interesting point was because the end of the trial coincided with the end of financial year, which was quite stressful. We can see in the walking group, they actually increased their anger, probably stress-induced anger over the trial, whereas those who were doing the effective movement training dropped their anger over the duration of the trial. Then for looking at the cognitive test. So a serial 3's reaction time that's how quickly you can count backwards from any number, say starting at 168 and counting backwards in 3's. We can see the walking group improved ever so slightly as time went down, but those who did effective movement training improved significantly, and the same result seems to happen when they counted back in serial 7, so in groups of 7. So that's an aspect of what we call executive function, the ability to do quite complex tasks. Choice reaction time is just a simple test of how quick the brain is at making choices. And you can see both groups improved, but the exercise group, the EMT group, improved significantly more due to the slope of the line. And this is an interesting one, alphabetic working memory. This is really quintessentially what it is to be human. It is the ability to hold different bits of information in the brain at the same time and to be able to forecast into the future and make decisions. So this bit was alphabetic, so looking at their ability to hold numbers in their brain. And we can see no change in the walking group, but the EMT group had quite a significant change within that. Then moving on to some more complex brain functions. Now, some researchers have called the Stroop test like a stress test, like you get for the heart, a stress test. This is the same for the brain. So the brain is trying to work quite hard. You can see on the right, the reaction time improved much greater in those doing EMT. And then incongruent is where the brain has got all this conflicting bits of information. So really needs to work quite hard under load or pressure. And we can see with these higher order brain functions, the walking group didn't improve much, but the exercise group was pretty significant. And then the last bit on cognition was looking at speed and accuracy. So there's a trade-off between speed and accuracy in the brain. And we can see pre and post, what happened was the control group or the walking group, they got slightly more accurate on this task, but they had to slow down because the time increased. So they had to slow down because they knew it was quite a hard test. Whereas the guys who did the EMT, not only did they get more accurate, but they actually decreased their time, so they sped up. So the brain was getting quicker and more accurate, which is pretty cool stuff. What also happened was the walking group improved their biological age or their bioage in the study by a period of a year, whereas the exercise group improved by 5 years on average over the study. So what are some of the possible reasons for this? Well, we know effective movement training is about functional movement. It's up on your feet. It's moving in 3 dimensions, moving in all different directions with the hands and the legs. And the cerebellum gets heavily involved in this. We used to think the cerebellum was purely to do with postural control. We now know it is involved in higher order brain functions as well. So that is a theoretical reason why this type of training actually had a bigger impact. We also know the right cerebellum, when you move your right arm and right leg, is connected through to the left cortex and vice versa. So that way you can get whole brain activation when you're doing more complex movements. And we know brain rehab exercises do stuff about crossing the midline, which we do a lot of in EMT as well. So it's really looking at brain rehabilitation and taking that and applying it in an exercise setting. So we know that you get synaptic plasticity. So the synapses actually become more flexible and increase within the cerebellum when you do complex motor skill training. So possibly that not only improves your ability to do motor skill, but might have an impact on overall brain function. Because we know that when the brain is developing, there's very close interrelations between motor development and cognitive development. And it's that interaction between the cerebellum and the prefrontal cortex. So it seems reasonable to assume that that would continue as an adult. So the complex movements can actually help brain function. The other reasons why we think this is contributory is all of these growth factors that are produced in the brain. These two, FGF and VEGF, they help to increase the amount of little capillaries that are in the brain and indeed all over the body. Insulin-like growth factor is important in learning and memory. We know endocannabinoids are released during exercise and they have an impact on brain function and certainly mood as well. And the superstar of the show is BDNF, a brain-derived neurotropic factor, which is very important for brain function. We know it is protective against Alzheimer's, against head trauma, against if you have a stroke, it's protective. We know that BDNF levels are low in obese people, in people with dementia, in people with heart disease, in people with diabetes, and so on. So BDNF seems to be really key, but all these growth factors are important. And also the intensity of exercise seems to be pretty key in releasing these growth factors. And when you do effective movement training type techniques where you're up on your feet, you're using full body movements, you get much more of a metabolic load. So you get more of these growth factors in the brain. And we know that endocannabinoids and exercise, they're released during exercise and they have an impact on our well-being as well as helping to manage our stress. And we also know that BDNF, and the biggest source of this is through exercise, and particularly with increasing intensity of exercise. So doing those complex whole body movements is not only good for your body because it's aligned to functional anatomy, but it is also good for your brain. So if you want to train your clients effectively, then effective movement is the only clinically proven tool, exercise resistance training tool in the world that is clinically proven to improve brain function as well as bioage.